Yes, good evening guys to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. And guys, today is the last session of SOM in the 50 mark series. And guys, today's topic is very interesting, that is SFD BMD, which is very important for both the branches. If you talk about mechanical, civil, in both the branches, question is coming from this topic. Okay, so this is very important. So guys, please tell me, am I properly audible and visible to all of you? Let me check the voice. Voice is coming or not? Yes. Everybody. Fine guys. Okay. I can see the messages. Anubhav, I am fine. Rakesh, hello. Yes. Pejal word, hello. So guys, today we are having the questions from SFDs and BMD. This is some detail about me. And the subject for today's discussion is strength of material. So guys, now before we start the session, there are two important information. One is related to the scholarship test. On 9th of July, 9 AM, you can go for the scholarship test and you can get up to 90% of the scholarship on the GATE preparation program. And then, my dear, there is a workshop at 7:30 PM on 11th of July will be taken by Joshit Singh sir on the topper strategy to secure AIR 100 in the GATE examination. So guys, now we are starting with the very first question. So I am having 10 questions for you today, and every question will give us some important concept. Like this is giving you the concept of compound beams. Like, you know, whenever we are having the internal hinges and beams are joined in series, we call it as compound beam. So this is the very first question which will be using the concept of compound beam. Akhilesh, good night we say whenever we are leaving the session. Okay, it is not like with the time we say good night only. So here you can say good evening. Okay, yes, good night means you are going to sleep. So guys, just we will try to solve this question. The reaction at B due to the load as shown in the figure. Will you try this? You need to find out the reaction at B, my dear. So you know, actually reaction will be coming at 3 points. At A, at B and at E. So you are also aware of that I can go for summation vertical forces to be 0. And then we can say reaction at A is RA. Reaction at B at RB. And reaction at E is RE. So you can write this as RA, write this as RB, write this as RE. And together they are bearing the load W. Yes, Vineet is saying B is the answer. Vineet is saying B is the answer. What about others? Vineet is saying B is the answer. Okay. Pejal word is also saying B. Yes, good evening, Vineet. Okay, fine. We will see. Rakesh, Anubhav, you also try and tell me what do you feel, what should be the answer. Anubhav is saying A should be the answer. Okay. Very good. So guys, this is the very first equation. We are having 3 unknowns here. Then my dear, you can also consider the summation moment at some of the point to be 0. Okay. So, okay. Any other answer? Then we are going to start. Any other answer? So my dear, whenever we are talking about the moment at C, you know, this is the point of internal hinge. So moment at C will be 0 whenever you go from the left hand side or right hand side, because at internal hinge moment is 0. So my dear, I am going to find out the moment at C from right hand side. Okay. So my dear, if you will be finding out, you know, RE will create anti-clockwise, W will create clockwise. So we can say RE into, this is 4 plus 1, 5. And then minus W into 4. So my dear, this will give us the value of RE because it should be 0. So you will be getting RE as equals to 4W by 5. So this is the value of RE. Now you got one out of these two. But my dear, still we need to find out the other. Okay, we need to find out the RB. We want actually this value. So my dear, for that we can also take the moment at some other point to be 0, like at point A. So when you will be taking the summation moment at A to be 0, then my dear, you can see this RE RE into what? 1 into 1 plus 4, 5 plus 2 plus 3. 3 to 5 plus 5, 10. It is RE into 10. RE into 10. This is creating anti-clockwise. This is creating clockwise. So minus W into. This is 9. Then my dear, we are going to have this RB. RB is acting in same RE direction. So you will be having plus RB into 3. So my dear, here you will put it to be equals to 0 because you are going to take summation moment at A to be 0. Here RE is known to us. RB we can find out. So when you will be finding out the RB, you will be getting the answer to be W by 3. So the answer given by Anubhav is the correct one. So please tell me everybody understood this or not. Then we are moving further. Everybody understood this or not? Please tell me. Then we will move further. Yes. Everybody got it? Very good. So answer for this is going to be A, that is W by 3. A will be the right answer for this. Very good, Anubhav. You have done it really nicely. So guys, moving to the second question. For other students, we need, don't worry. Page 1, don't worry. You have other chance. Very good, Prakash Khan. Answer is A. Moving to the second question. This is easy question. And for this question, I am expecting answer from everyone. Yes, so just try to solve this question, guys. I feel this question everybody would be giving the right answer. And do like and share the session, guys, because this is the last session of SOM and today we will solve 10 questions. And I have considered the concept with the questions. So every question will be on the different concept. So here we are using the concept of, yes, that hinge support. As you know about hinge support, there is no moment reaction. So this body should be in equilibrium. Body should be balanced. Okay, Sanjay Kumar is saying B. And Anubhav is saying the answer to be A. Okay, we will see. I am waiting for others to answer. Vineet, Pejal Word is saying A. Very good. What about others? What about others? So guys, you can see we are having a hinge support. So we are having a hinge support and hinge support is like this. Okay. And here we are having a UDL. Here we are having a UDL of W kilonewton per meter for a length of X. You know, whenever we have UDL, we can consider it at centroid. So we can consider W into X acting at a distance of X by 2. Similarly, on the other side, we are having a UDL of double intensity. This is 2W for a Y distance. So you know that there also we can consider it as on the centroid. This is 2W into Y and acting at a distance of Y by 2. You know about the hinge, that moment should be 0, then only the body will be in equilibrium. Otherwise the beam will rotate under the load. So here we are using the balancing symbol. So my dear, we need to just balance about this. This is point O. Let us say summation moment about O is equals to be 0 net. So whenever we will see the moment, because of this you will write W into X by 2. Then you will write because of this minus W into Y by 2. But this is 2W. Okay. So you will equate it to 0. Then my dear, you can say WX square by 2 is equals to 2WY square by 2. So my dear, 2 will get cancelled out, W will get cancelled out. So you will be getting X square as equals to 2Y square. So X will be root 2Y. So the answer for this is D. D is the right answer. Okay, Arun have given the right answer. Very good, Arun. Okay, Arun, why you have not attended the yesterday's class? I was looking for you because stress strain diagram is very important topic. If you have missed, try to watch the recording. That will give you many new ideas, many new types of questions. Akhilesh, very good. Moving to the question number 3, guys. This is on the overhanging beam. First question was on compound beam. Second question, okay, you were there, but you have not messaged anything. Okay. So second question was based on which? Second question was based upon the concept of what? It was hinge. This third question is based on the overhanging beams. So let us solve this question. A simply supported beam with equal overhang on both the sides. Let us say the overhang is A. Let us consider the overhang is A. And they are asking if the bending moment at midspan is 0. This is the midspan. Let us say this length is B. Total is L. So we are going to find out if the bending moment at midspan is 0. Find out the percentage of overhang on each side. Okay, Arun, no issues. So guys, just solve this. This is a wonderful question. And do like and share the session, guys, because it is very important to solve this type of question as per looking the level of gate nowadays. है ना? Okay, Vineet, don't worry. We will come up. We will come up. Don't worry. Now we will be starting those kind of topics soon, because now the exam, now students are becoming serious. So from July onward, you know, we are also increasing the number of classes. Previously, we were having 3 classes a week. Now it is 5 classes a week. Okay. We will have those topics in the pipeline. Don't worry. Pager word is saying the answer to be A. Okay. Pager word said A. I will wait for others to answer. Already Regan have also answered it A. Fine. Prakash is saying the answer is B. So we got 2 answers till now. Waiting for others to answer. Okay, Regan also is saying now B. So Regan said ki it is not A, it is B. Okay, fine. So guys, let us try to solve it now. We will be considering a support reaction. This is RA. This is RB. This point is C, this point is D. So my dear, we can directly write by symmetry. RA will be equals to RB. Why? By symmetry. So by symmetry, both are going to be equal. And they will be equals to what? They will be equals to total load divided by 2. Yes, very good, Regan. Total load is W into L. Total load is W into L. So you can write W into L. Okay, this is the total load. So my dear, it is divided by 2. Obviously, yes, divided by 2. So you can also write it as W into 2A plus B divided by 2. This is the support reaction. You are saying that bending moment is 0 at the midpoint E. This is 0. So first of all, we need to write down the bending moment at E equation. So my dear, we are writing the bending moment at E. You know that because of UDL, you will be assuming the total load to be at center. And what is total load? This is W into A plus B by 2. That load will be acting at a distance of A plus B by 2 divided by 2. Or you can also consider it to be as L by 2 directly. Okay. This is how it is going to act. L by 2 ka 2. L by 4 it will become. Is it clear? So my dear, we can write this will be creating anti-clockwise. So minus W into A plus B by 2 into A plus B by 2 cut half. You can also consider it to be L by 4 directly. Then my dear, you will be having, because of RA clockwise, so it will be RA into what? Into B by 2. RA into B by 2. So when you will be saying this is going to be equals to 0, so you can write it minus W into A plus B by 2. This is by 2 I will be doing. And once again A plus B by 2. Minus, sorry, plus. This is minus. What is the second quantity? As you know, it is equals to 0. So we can put it equal as well. Equals to. We can also write equals to. Then we will be going for the equals to, and you will be having on the right hand side this W into 2A plus B by 2 into B by 2. So you know that already that A plus B plus A. So 2A plus B. 2A plus B is equals to L. You know that. And here also you know that this A plus B by 2 is nothing but L by 2. So when you will be putting this, you will be getting that A will be coming out to be 0.25 times of L. It means 25% is the overhang on both the sides. So 25% loading or overhang is here, 25% overhang is here, and 50% is going to be this. So from this you will be getting the answer to be B. So each side overhang you will be getting as 25%. So B is the right answer. Everybody understood? Very good, Prakash. Yes, Vineet, you got the answer or not? Arun, you got the answer or not? Please tell me that. Everyone. Bolo bhai. Anubhav have given the answer. Prakash given. Pagel word, you got it or not? Pagel word, you got it or not? Okay. Fine. So moving further, guys. This is a question where we are given the shear force diagram and they are asking about the loading diagram. They are asking about the loading diagram. They are saying that we are having a concentrated load at point B. This is point B. A concentrated load at point D. This is point D. A UDL between CD. This is CD. So you need to tell which of the statements are correct. We are taking all the types of questions, guys, in the classes. Just solve this question. I feel this question you can answer. This question you can answer even without my help also. Try to solve it. Try to solve it. Okay. Shubham is saying the answer to be D. Yes, very good, Arun. Very good. So CD is the part of CE. If CE take UDL, CD also take UDL. Okay. So what the answer we got as D from many of the students. Okay, no issue, Vineet. Ram is also saying the answer to be D. Abhishek is also saying the answer to be D. Very good, very good. So guys, I would like to say the answer is D because wherever we have the concentrated point load, we have the jump in the diagram. So we are having the jump at B, we are having the jump at A, we are having the jump at C, we are having the jump at E. So my dear, at A, B, C, E, at all these 4 points, we are having the point load. So obviously the first statement is going to be correct. Then my dear, we are having this inclined line from C to E. So this is coming when the loading is UDL. So my dear, obviously we are having UDL from C to E. CE portion is under UDL. So obviously CD part is also under the UDL. So third statement is also correct. But my dear, at D we do not have any point load because there is no jump at D. So second statement is wrong. First and third will be the correct one. Naidi Prakash, when they are saying, they like, let us say, they are saying C to E is the UDL. But C to D is also the UDL. No? He is talking about only CD. Okay, it is like you are studying for 6 hours, from 4 to 10. If I say that Prakash was studying from 8 to 10. So 8 to 10 you were studying because I have not seen the other timings. So that is correct only. Okay. So when CE is in UDL, CD is also in UDL. No? That statement is not wrong. He may be not talking about E. Like you know that he is saying a concentrated load at B. You can say, sir, he is saying wrong. Load is there at A, at B, at C, and D. But you don't say that. Why? Because you know he is partially talking. Okay. Got it, Prakash? The logic? So answer will be D for it, for sure. Moving to the next question, guys. This is for the definition of contraflexure. As I said, every question I am taking to tell you about one concept. So if you know what is point of contraflexure, you can very easily give the answer to this question. So I have kept this session with questions, some difficult, some easy, some tricky, so that you get all the tastes together. Anubhav and Prakash have given the answer to be C. Ha, Ram, you are saying, one second. From C to E, we have UDL. At C, we have point load also. Yes, at C, you will be having the starting of UDL and point load both. It is possible. Like, if I am showing you C, you can have this. Okay? Moving further. Okay. So guys, the answer whenever we are talking about the bending moment diagram for an overhanging beam is shown, the point of contraflexure would include. So my dear, point of contraflexure is the point where bending moment is changing the sign. Point of contraflexure will be the point where bending moment changing the sign. So C and D. So CD is the area which include both the point of contraflexure. So answer will be C for this. Okay. So CD is the portion which is going to have both the points of contraflexure. Point of contraflexure where bending moment changes its sign. Okay. So guys, moving to the next question. Here we are having a uniformly variable loading. Diagram is missing, so I am making the diagram for you guys. This is the diagram. This is W1, this is W2, and this is point A, this is point B. You need to find out the shear force at the support B. Shear force at the support is nothing but the support reaction. So you need to find out the value of RB, my dear. You need to find out the value of RB. This is going to be RA, this is going to be RB. So you need to find out the support reaction at B only, because that will be the shear force. So my dear, what you need to find out? You need to find out the value of RB. That is what is required. I feel everybody would be able to do this. This is a very easy question. And guys, to get the PDF of this session, you need to join my Telegram channel, Mechanical by Dheeraj Sardana. And there you will get handwritten notes of strength of material and all other subjects related to mechanical. Okay, but common subject like strength of material, like fluid mechanics, like engineering mechanics, like mathematics, you will get there. Okay, and also this PDF and also some other sessions, notifications. If any new vacancy comes, you will get each and every detail. For this question, Ashutosh, Akhilesh, Shubham, they are saying the answer to be C. Okay, I am waiting for others to answer and I will be solving in front of you this. First of all, you know, we can write RA plus RB is equals to the total load. Total load can be considered as UDL plus UBL. So that UDL will be W1 into L. What is UBL? UBL will be this triangle. So for this triangle, I will be considering this height. This height is W2 minus W1. So it will be half into W2 minus W1 into L. So guys, we can also go for the shortcut. If you are considering this a combination of UDL and UVL, you need not to go for any calculation. You can directly go for the shortcut. So you can consider the total area of this UDL at its centroid, which is nothing but equals to W1 into L, which will be acting at a distance of L by 2 from both the ends. And simultaneously, that centroid of the triangle will be coming somewhere here. So you can assume the area of the second triangle somewhere here. So my dear, this area is 1 by 2 into W2 minus W1 into L, and that is acting at a distance of L by 3 from here and 2L by 3 from here. Now it is very, very easy question for all of you, I feel so. Okay. So Arnab is also there with us. Very good, Arnab. So you guys are saying the answer to be C. So my dear, whenever you want to find out RB, what you will be doing? You will be saying because of this, it is going to be, you can see RB upward, load downward. So sign will be positive. The value will be W1 into L, and you know total length. Okay, you will be multiplying it with the distance from the opposite end is L by 2, and total length will be L. This is the effect of WL. Then we will be having the second effect. This is upward, this is downward, sign will be plus. Then area is half into W2 minus W1 into L. Okay, acting at a distance of 2L by 3. The total length is L. So my dear, you just need to solve this to get the answer. What you will be getting? Here we are getting LL cancel out. This is W1 L by 2. So W1 L by 2. And here we are getting, this is half W. Okay, LL will get cancel out here also. So we are going to have plus 1 by 2 into W2. 2L by 3. And then we have minus 1 by 2 into W1 into 2L by 3. So you know 2 will get cancel out, 2 will get cancel out. So I feel the answer you will be getting, this is, okay, this is question number, let me check. Okay, this is 3, 4, 5, 6. So 6 question answer is C, you are correct. So finally you will be getting W1 L by 6 plus W2 L by 3. The answer is correct, guys. Wonderful, everyone. So guys, now we are moving to the next question. Next question is question number 7. We have 3 more questions after this. This is from the relation of load intensity, shear force and bending moment. This is from the relation of load intensity, shear force, bending moment, slope and deflection. They have given you the equation of deflection. But you need to find out the value of shear force. This is a new type of question. So I will give you the hint that whenever you have V, you must be aware of, this is the deflection. Whenever you will be going for dy by dx, if this is deflection, this is slope. One more differentiation. This will give you the bending moment. Okay, one more differentiation. This will give you the shear force. So you need to differentiate it thrice and then put the values. You will get the shear force. No. There is no Castigliano equation used here. Castigliano equation is the part of deflection chapter. This is the question from SFD BMD. This is not the question of slope and deflection. So you just need to go for this relation. Deflection to slope, slope to bending moment to shear force. Castigliano theorem already is taken by Abhinav sir in this series already. No, it is not even strain energy, Arnab. It is not even strain energy. This is the relation simply. Deflection, differentiation will give you slope. Slope differentiation will give you bending moment. Bending moment differentiation will give you shear force. Because you are aware, na? EI into d square y by dx square is equals to mxx. Okay. So this is the equation for bending moment. Do you know that? So here they are representing y by v. So my dear, this is bending moment. So you need to first find this equation. And you can write this EI d square y by dx square is mxx. And when you will be writing dmxx by dx, which will be equals to shear force. Okay. So it is nothing but dqv by dx cube. So you just need to differentiate this thrice, put all the values and get the answer. Ha, that is correct. Okay, Prakash Khan is saying 4 EI by L. Dear whenever you see the values, they have given the value of bending moment, they have given the value of length. The answer will be coming not in terms of EI, it will be coming in the Newton, because EI will get cancelled out. Okay, EI will get cancelled out. Don't worry, I will do it for you. Don't worry, I will do it for you. So I am also starting parallelly. We are having the equation V of x is equals to m naught x cube minus x square L divided by 4 EIL. We are going to differentiate it. You will go for dV by dx. dV by dx will give you m naught into 3x square minus 2xl. 4 EIL is constant. Then you will be going for d2v by dx square. This will give you m naught 6x minus 2l. 4 EIL. Then you will be going for dqv by dx cube. It is m naught into 6 4 EI into L. Is it clear? Yes, very good, Anubhav. Anubhav and Arun have given the right answer. This is 1.5 Newton. Is it clear for everyone? Yes. So you know that d square v by dx square is m upon EI. That you know. Okay. So when you will be going for d cube v by dx cube, that should be equals to what? You know that whenever you will be doing this is going to be 1 upon EI will be equals into dm by dx. So dm by dx is nothing but the shear force. So shear force, what you want to find out is EI times d cube v by dx cube. So you will be having EI into m naught into 6 divided by 4 EI into L. EI cancel out. Put value of bending moment m naught as 100, this as 100. Okay, you will be getting the answer to be 1.5 Newton. Okay, very good guys, very good. So how you find the level of question, whatever we are doing, you are enjoying or not? Are you getting something new from every session or not? That is what we are looking for. Okay, so guys, we are coming up with ISRO series separately, GATE series separately. But if you are going to give any exam, both series will help you. Okay, both series will help you. Very good, Anubhav. Thanks for your feedback, Arun and Prakash and Arnab. So this is simple question because previous one was tricky. This is simple. So we have made the balance also so that you shall not be getting demotivated also. So we are having all the qualities. Like GATE is also asking. GATE is asking hardly 10 to 15% very difficult question. All others are mediocres. So we need to prepare for everything. Tricky question, difficult question, lengthy question, everything. This is easy question. They have given you the bending moment equation. 5x square minus 20x minus 7. You need to find out shear force at x is equals to 2. Thanks, Asutosh. So you just need to do dm by dx. That is nothing but the shear force. Put the value of x, you will get the answer. Okay, Regan is saying 0. Dear, at x is equals to 2, you need to find out the shear force. Everybody is getting the 0 value. When you will go for dm by dx, it will be 10x minus 20. When you will equate it with the 0, x is equals to 2, shear force will be 0. Okay. So you got A as the answer. Very good. Fine. Very good. So moving further, guys. Moving further to the next question. This is a very good question. They have given you SFD and you need to choose the correct loading diagram. So previously we were asking only about the load. Now the diagrams are in front of you. This is the question number 9. We have two more questions after this. We have two more questions after this. So guys, just do like and share the session. We are still left with two more questions after this. Okay. So you can see, first of all, you have jump here. You have jump here. Jump here. Jump here. So there must be 3-point loads. There must be 3-point loads. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Every diagram have 3-point loads. Okay. So my dear, you know this is variable slope line, inclined line. So for this length, we must have UDL, 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 UDL. So we need to use the sign convention here. So Shubham is saying A, Arun is saying D. So my dear, you know the convention of the shear forces. This is positive shear force, negative shear force. So you know that here is a downward jump. Downward means negative. So negative means to the left of the section. To the left of the section, jump should be here. This is the jump of 47 kilonewton. So the same jump we are having here. So obviously C cannot be the right answer, B cannot be the right answer. Answer is going to be either A or D. And two students have given A, D, D. Okay, Anubhav also, Prakash also A. Majority students are with A, some are with D. Then you are having downward increasing, it means UDL also will be downward. Okay, so here only A is correct, this is wrong. Because if this downward is downward loading, so this downward should also be the downward loading. So why you are saying D? D is wrong. A is the right answer. Regan, you got it? Regan, you got it? After that you have upward jump. So there is the upward force. There is a downward jump, there is a downward force. A is the correct answer. Fine. Regan, you also got it? No issue, Arun. So guys, this is the question number 9. And now, my dear, we are going to move to the next question. Next question is question number 10. Next question is question number 10. Arnab, you can do it. You can do it from right hand side. Whenever you take this section to the right hand side. Okay. So you will be starting from 0. Now, always remember we started from 0. So there is upward jump. Okay. So to the right hand side. To the right hand side, downward is positive. So it means load will be coming downward. Then also you will get the same answer. Okay. So when you see right hand side, you will start from 0. It is upward. Okay. Upward means positive. Okay. So for positive, load should be downward. So then also answer will be same. This is the question number 10, guys. Question number 10. If the beam shown in the figure given below to have zero bending moment at its middle point, it is similar question what we have already done. This is the middle point. This is A, B, C, D and E. And you need to find out the overhang X should be what. But they are asking this in terms of load now. That is the difference. विनीत 9th क्वेश्चन में रिवर्स क्या पूछा था? यही तो पूछा था. This was SFD. They have asked loading diagram. Okay. So here, my dear, first of all, by symmetry, RC equals RD equals P. Okay, by symmetry, both reactions will be equal. So in that case, you can write down the bending moment at E. That will be coming because of this P. P into X plus L by 2. This RC will be, this is anti-clock. Anti-clock I am taking positive, so clockwise I will take negative. Then plus W into X. X is simply L by 2. So W into L by 2 into L by 4. That you just need to equate it to 0. When you will be equating it to 0, RC is also P. Okay, and you will be getting the value of X. Solve this and get the answer. Okay, fine. P plus WL by 2. Sorry, guys. This will be P plus WL by 2. I have not considered this load. Fine. P plus WL by 2. It is correct. Very good, Arun. Thanks for correction. Okay, Arnav. That's fine, but I am not aware of that because at that time I was not present. That's why I was unable to take the session in that series also. So I feel Abhinav sir would have taken that. What would be the answer, guys? You need to find out the value of X. This is the second last question. So please give the right answer. Vineet, but as I said, nowadays we are getting questions different than the previously asked cases. So that's why we are taking all the possibilities. Okay. So my dear, you are having this Px plus PL by 2 minus RC is P plus WL by 2. So RC will be P into L by 2 minus WL by 2 into L by 2, WL square by 4 plus WL square by 8. We are equating it to 0. I feel this and this will get cancelled out. So you will get Px WL square upon 8. So you will be getting X WL square upon 8P. C will be the right answer. Okay, everybody got it? Prakash, when you will put this value of RC here, PL by 2 will get cancelled out. Everybody got their mistake? Abhishek? Yes. C would be the right answer for this. Just look at it. Okay, sabji jal gaya. Sorry, Arun, for that. Fine, guys. So everybody got it? Shall we complete the session with the last question? Shall we complete the session with the last question? So the last question is in front of you guys. Question number 11. If you see the figure, you will leave the question. If you see the figure, you will leave the question. But when you will try to solve, you will answer without solving. Okay. So let us see how many of you are going to use the brain here. If you will try to see the figure, you will say leave it. This is very difficult. But this question is a two-step question. Whenever you see difficult figure, difficult or lengthy statement, those questions are very easy actually. Those questions are difficult which have small statement. Okay, lengthy questions are always easy to solve. Very good. Regan have given the answer. So my dear, this is the internal hinge. This is the internal hinge. So from here we can separate the beam. We can separate the beam and other part would be as it is. Like, you know, here we are having point B. Here we are having the support. Then we have UBL. Then we have UDL. Here we have support. Here we have support. So my dear, you can see this is 2 kilonewton. Okay, 2 kilonewton. This is 20 kilonewton. My dear, if I divide this 20 as, let us say, I am saying this to be 10, this to be 10. I can say it like this. So you know this 10 kilonewton, if this is the distance x, this will be balanced by this support reaction. So this RA will be coming out to be 10. But my dear, whatever the moment will be created by this 10 into x, that will not be balanced by this support. So because of that, here the load should be 0. And if here the load should be 0, this RA should also be 0. So they are asking in this question, find out the magnitude of the shear force immediate to the left and immediate to the right of the section B respectively. So my dear, just before point B, there should be 0 load. Otherwise, this support will not be able to balance the moment. And my dear, just after this, we are having this 20 kilonewton. So answer will be 0 and 20. C will be the right answer. So whenever you see this type of question, never lose hope. It is very, very easy question, my dear. So guys, now please tell me you enjoyed the session or not. I am telling you, if you are preparing for ISRO, from next week, Monday onward, we are starting a series for ISRO where we will revise formulas for first 15-20 minutes. After that, we will go for the question which ISRO is asking, that type of question. This 50-mark series is going on, and guys, now on weekends you will see me with some wonderful questions, okay, and you will enjoy that. So be ready and enjoy this 50-mark series and other sessions at this channel. And just, okay Prakash, we will arrange that. Yes, Arnav, that is 0. So guys, I would like to tell you one more thing here, that just join my Telegram channel Mechanical by Dheeraj Sardana to get the PDF of this session. And also, I will be soon coming up with the previous year's question of XC paper. Because if you are going for civil or mechanical, you know questions are as it is coming from XC paper. So I am soon coming with that. So be ready for that. हाँ बिल्कुल 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 शुभम, from next week I am telling you here only, every Saturday you will have a session on non-tech. Every Saturday you will have a session on non-tech, and if you will be coming in more number, I am ensuring you we will increase the frequency also. Okay, so I feel this is the end of the today's session. We will be coming up live with such more sessions, so be there with us. Join Telegram to get the PDF of the session. And goodbye, good night to all of you, and thanks for joining, guys.